Okay, calculus. Today we're going to start our study of chapter 6 and we're going to open up with slope fields. One of the big goals today is just to get you to draw a slope field and to kind of understand what you're looking at. This part right here, we're going to go through this slide on a different day, maybe Friday. Okay, let's start here. All right, this is a differential equation right here. This one's given to you. And basically it says that the slope of a line is 2x. So what you're going to be doing is you're going to be plugging in each ordered pair into this equation. There's no y in our equation, so we're just going to take the x value times 2. So go ahead and fill in your chart, multiplying every x times 2. Seems a little redundant, but it's going to be okay. Okay, once you have that done, then we're going to make a sketch of the slope field. So you're literally sketching like a stick at each point that would represent the slope at that particular point. So we know that negative slopes go downhill. A slope of -6 will be steeper than a slope of -4. A slope of -2 will be not as steep as a slope of -4, and so on. If we have a slope of 0, that's going to represent a horizontal segment. For undefined, we wouldn't put anything. A slope of 2 is not as steep as a slope of 4, and a slope of 6 is steeper than a slope of 4, and so forth. All right, so what I'm going to do first is I'm going to focus in on these guys right here. Those are my slopes of 0. So what I'm going to do is I'm going to take and just draw a little line segment at 0, -2, 0, -1, 0, 0, 0, 1, and so on. I could even go ahead and do my 3's. So that those all represent a slope of 0. Then I'm going to go ahead and keep going to the right. So I'm going to do all my slopes of 2. Now when I do a slope of 2, that's going to be steep, but not as steep as a slope of 4. So, and they're all the same slope there in that vertical line, x equals 1. So let's see here. Something like maybe this would be a slope of 2. And you're just kind of estimating what a slope of 2 looks like. Okay. Now a slope of -2 is on the other side when my x is -1. So I'm going to try to do the same thing but on the other side and going downhill. All right. Back to the right side, the next vertical line of slopes will have a slope of 4, so that's a little bit steeper yet. So try to steepen it some more. Steepen, I don't know if that's even a word. There we go. And then going the other way, try to make those look a little bit steeper. And then finally my slope of 6 is super steep, so try to make that even steeper than what you had before, but not vertical. Something like that. All right, that is your slope field. Now, that's taking care of item number 2 here. So we've done 1, we've done 2. Now, when it says to find a particular solution, one of the things that we're going to do is we're going to just kind of sketch where we think the curve's going to be based on this ordered pair. And then we'll solve our differential equation to actually give us an equation that would go through that particular point. That's the part of the lesson we're going to do on a different day. Okay, 0, -1 is down here. So you can kind of see that your sketch is going to kind of come in through here. Now, you don't want to disrupt your slope field, so you're just going to sketch it in there like so, and that could be it. This, honestly, it could also look like something more like, get that erased here real quick. One more. It could look like something maybe a little bit more steeper, something like that. So we don't really know. All we know is it's kind of got a parabola shape and it goes through 0, -1. What you don't want to do is disrupt that slope field. So you want to try to stay away from those slopes, but it looks like right here I kind of hit it, but that's okay. I think you get the general idea. All right, let's try this one. This one says we're going to double all of the y's. All right, so let's go ahead and fill all of that out. All right, so it looks like if I want to start here, any point that has a y value of 0 is going to have a horizontal slope, a slope of 0. So it's going to be, get that back. So those are the ones I'm graphing first. So anything on my y-axis has that slope of 0. Okay. Let's see. When my slope, when my my y is 1, my slope is 2. So I'm going to try to graph this line next. So again, when my y is 1, my slope is 2. So something maybe like this. All right. When my y is -1, my slope is -2. Okay. When my y is 2, my slope is 4. So a little bit steeper. But when my y is -2, it's -4. And then you could do the 3's as well. Okay. Now, this is what I have for a slope field. I want to graph something that's going to go through 0, 1. So 0, 1 is right here. Okay. You're not going to be able to cross over those slope fields. You don't want to disrupt them. So you're going to be drawing something in. Oh, and I forgot a few slopes. Hang on. I forgot this one, and I kind of forgot this one. There we go. All right, I want to draw something in that's going to go through that point and kind of go in there in between my slopes. Something like that. All right, then we have this third one. We're going to take half of the product of x and y. So what we're going to do is multiply x and y together and then divide by 2. So -2 times -3 is 6. So divide by 2 would be 3. And then we're going to have 3 halves, 0, -3 halves, -3, 2, 1, 0, -1, -2, 1, 1/2, 0, -1/2, -1, 0, 0, 0, 0, 0. Okay. Again, I'm going to go through and find all of my slopes of 0 and start there. So negative 3, 0 has a slope of 0. Negative 2, 0. Looks like anything with 0. Something like that. Okay. I don't really have any other tricks for you other than just kind of pay attention to what you're graphing. So if I start here at negative 3, negative 2, I have a slope of 3. So I'm going to make that kind of steep. When I go to negative 3, negative 1, it's 1.5. So rather than a slope of 3, it's not going to be as steep, something like that. And then negative 3 halves, so, and then negative 3. And then negative 2 is a slope of 2. And then a slope of 1. And then negative 1. And then negative 2. And then a slope of 1. A slope of 1/2, a slope of negative 1/2, and a slope of negative 1. On the other side, 1, negative 2, slope, slope, 1/2, 1, oops, let's do that one, not as steep. And a slope of negative 2, negative 1, 1, 2, and then negative 3, negative 3 halves, 3 halves, something like that. Okay, as far as the AP test goes, they aren't, these are sketches, but I would say they would definitely dock you points for like if your slope was supposed to be 1/2 and you gave it a slope of 2. So watch that. You want to be in the ballpark, but you don't have to be perfect. Okay, so we're going to try to find a solution that goes through 0, negative 1. 0, negative 1 is right here. So maybe we can't cross that horizontal line of slopes, so maybe it's something like that. And again, we'll be working on getting the exact equation down the road. Okay, we have this one here. This is our last one. So what I want you guys to try to do, I'm going to assign this one as part of your homework. I want to see what you guys can come up with. You can snap a picture of this and submit it back to me. I'll let you know in my slide, my announcement slide, if I want it submitted or if I want you guys to email it to me. I really haven't decided that yet for this video, but I know this is going to be homework. And then I'm going to also assign some of the worksheet that you guys picked up the last day of class as well. So reach out if you have any questions, and the next video we'll come back to this packet and we will work on how to actually calculate the equation for each of our slope fields. That's it for now. Hope all is well with you guys. I miss you. I miss your chattiness. It's very quiet here at my house. We're going to have a conference call soon just so we can catch up with each other. I'll talk to you guys later. Bye.